Good afternoon.
Hey, good afternoon. Okay, I think we have all the three presenters. So yeah, good afternoon, everyone. Welcome to the ARS Spring 2025 capstone presentation session. I'm Namrata, and I'll be presiding over this session six. So yeah, we are very excited to hear from our three students who has been working hard on their capstone projects. So I'll just go through some quick presentation points. Each student will have 15 minutes to present, and I'll notify them with a message when they have 5 minutes remaining. So we have to hard stop the presentation exactly after 15 minutes. So, and this session is being recorded, so please keep that in mind. After the presentation, we'll open up for the Q&A, and I'll be asking people if they have any question. So yeah, let's get started. So help me welcoming our first presenter for today. We have Jonathan, who will be presenting today's first session. So, yeah, please go ahead, Jonathan.
Okay, great. Thank you so much, Amrita. Let me share my screen and we can get going. Alrighty. So yeah, my paper is titled "Sweetening Honeypots with Realistic Network Activity." We are going to jump into our problem statement. So the problem statement for my paper revolves around creating high fidelity honeypots that simulate the industrial control system network topology to mislead and monitor malicious activity. I wanted to create a high interaction honeypot that would simulate a realistic target, but at the same time limit security risks to the system. Industrial control systems are sort of systems that supply essential infrastructure. These are systems like electricity grid, transportation, building environmental control systems like HVAC. And why honeypots are so useful in these systems is that these systems are usually very odd-shaped network topologies that we don't normally see in IT. A lot of times they have multiple types of connectivity. So there's satellite and microwave radio, as well as traditional IT networking involved in them. And the part of the background of why this is such a big issue is that these systems are not only being attacked by sort of lone wolf actors, like what we typically think of as hackers, but also they're involved in state-sponsored cyber attacks. In 2011, this was a big turning point where the U.S. and Israel launched a cyber weapon called Stuxnet against Iran. This was able to destroy a lot of their uranium refining equipment in their refinery there. And then sort of like since then, we've seen an escalation of nation states kind of doing a tit for tat attacks against each other. So yeah, these are some examples of that. And these are like pretty substantial attacks. Like this one in 2016 against Saudi Arabia, this actually caused the price of hard drives to change because they had to replace so much hardware that it actually affected the price of the good. And this is continuing to today. Not what we're seeing now is attacks against U.S. Essential services. So yeah, this is a big deal. honeypots are kind of uniquely positioned to help with this because they're able to sit on a network and um, attract malicious actors in by presenting uh, presenting like a juicy target, right? And so these are some of the key related works which I use to sort of get an inspiration for creating my own honeypot. This one worked as was able to be deployed on a Raspberry Pi device that was able to get just kind of plugged into whatever network they wanted. And then anytime an attacker went onto this device, they were able to isolate that as a threat actor. And this is another system. This one's pretty interesting as this was rather than attaching a piece of hardware device to a system, they were actually able to create the honeypot inside of a network interface card. And so based on the location of the request for information, they were able to isolate out malicious activity. And then this is this honeypot would isolate attackers. This kind of worked backwards, where they would scan network activity for malicious actors or network anomalies, and create the honeypot around the actor. And then this is like a fourth strategy where this was used in a port system where they had a digital twin created, and they're able to leverage that to create a virtual network based on the digital twin information that they had. So the related work kind of like broke down in the following categories, right? We had most of them were or either diversion activities, or would actively filter, and then they're also like in different types of interaction levels. So in our approach, we kind of broke it down into three levels, right, or three main programming activities. The first being the attack vectors. The second was just creating a realistic system using a actual SCADA system. In this case, I chose FUXA to do that. And then the third is to emulate Modbus devices on the system to create a realistic network activity. So this is kind of the use case model. An actor kind of attacks the network through SSH. That connection is then proxy passed into an SSH target. In this case, it's a Ubuntu server. And then from that target, the attacker is able to gain sort of understanding of the network, and they're able to see the different network activity that's happening in the system. And this is sort of the deployment model. All these are nodes within the Docker system. The honeypot kind of creates most of the logic, and it passes the attacker into the SSH target. And in that network, they're able to, see the different nodes that are in there, and the devices, which are Modbus servers that are responding to the SCADA system. Those take sort of like a basic global state from the honeypot. And so the system that I created kind of fits into the same matrix, in that it's a diversion system, and it's a sort of high interaction based on the amount of network activity that's happening on it. Yeah, so essentially that's what the system is. I'm kind of going to go into a demo, and then And then I'm actually going to circle back around to the future work because the future work makes sense more after the demo. So this is my demo. See all the different services. First service here is our SCADA system, followed by the target. See that it's built through a Docker file called target. This is the honeypot. This is sort of like where most of the app logic is and how we expose it to the outside world. And then here we see that we got our devices. These devices are built using the Modbus TCP Docker file, and they provided a path to a configuration file. And then, so in our target, this is running Ubuntu, and then we've loaded in these tools so that it seems like it's a workstation that's actually being used, right? This is sort of what the devices are. So next we're going to get our application up and running by running the Docker codes. See all our different services that are spinning up. This error is just due to the fact that our SCADA system, which is in the container labeled Foxa, is spun up quicker than our nodes. So we have, so they just can't find them. But now we can see everything's up and running. Here we can see this is the UI that's provided by the Foxa system. If we go into an editor, pretty much you can create as complicated a system as you want. Set the IP addresses of our device nodes in the connection to the Foxa server. And then when we go back to home, we can see the system running. These are the three devices. We have like a pressure gauge, a tank value, and then so we have three nodes that are running in our system. So the next thing we can do is head over to our straight we're able to SSH into our target. This is the command that we're going to use. We're asked for a password. See that we're in an Ubuntu target 04 version. This is different. This is like, even though we've SSH'd into our local host, this is getting directed like passed into the target that we've set up. Essentially, we're acting as a some of the commands that we've installed. Let's just know. So like let's see that there's some directories in here, and we did also in our we started. So see that is. This is all sort of being ordered. It's the end of the. Okay, and I just have one more slide. So this is just the future works. So as you can see in that demo, there's some issues with how the network is being reported. Mostly that you can see that it's a Docker container rather than running on an actual system. And so moving into future works, what I'd like to do is really take control of the network routing within the Docker containers. So, and then refactor the devices so they're not individual nodes, but rather services that service that type. So that the router is able to pass all that network activity to the appropriate device, and then introduce an idea, the concept of state, so that as the attacker moves through what they perceive as a network, the state of where they are within the network is being provided and returned to them. Cool. And so, yeah, that's the end of the presentation. Thank you. Yeah, does anyone have questions?
Yeah. Thanks, Jonathan. Does anyone have any questions for Jonathan?
Jonathan, can you hear me? Hey, Jonathan, can you hear me?
Yes, I can.
Oh, okay. So I know still this one needs your future works. So if you want to continue this one, what will be your next plans?
Well, so I was actually doing a little bit of research this afternoon. I need to set up I need to take control of the DNS server within the Docker container of my attack network. So that's really the next step. And then from there, it's to refactor my Modbus server so that's able to take like the IP and then the ID of the device that is emulating, so that it can take any IP address from the SCADA system. So that's really that's the next thing that I have to focus on.
Yes. Also, always I have this kind of question to the students who are finishing capstone. So what kind of advice do you want to give to the next student who want to take a capstone if they are interested in this kind of infrastructure security?
Yeah, I mean, doing more reading of the research, and I one of yeah, which is really good. I attended like a weekly meeting through the IC2AI, which is like um, an infrastructure security group, which gave me a lot of ideas on how to work on this. So yeah, just kind of like understanding the technology is, because it's kind of like weird. It's different from traditional IT networks and whatnot.
Okay, thank you.
Okay. Do we have any more questions? Yes, May. Please go ahead.
Did you make your own honeypot, or is it like you take a honeypot that was already made and then you kind of deploy it into the network?
No, yeah. So I made my own honeypot. Yeah, I made my own honeypot. I was using that SCADA system that I showed. That's an open source system that you can use. But no, I did do the only honey stuff. I guess I didn't mention that, but I was working in Go because it's a great program, like a network programming language. Um, and so yeah. And then yeah, so I guess there's like kind of layers of that. Like the actual honeypot, which is doing the logic. I did that. Um, the what you saw as the system that you came into was a Docker container that was running Ubuntu, right? So it was like an actual OS that was running. Um, Yeah, I'm not sure if I answered your question well, but yeah, I guess a follow-up to that was that I guess the cron pot, which is a honey pot that essentially does the same thing, but it works on a Debian based Linux system. So
Hey, I just want to say that I think this application could prove to be very versatile since you're using Dockers, right? It can be replicated and used on many machines from different factories because we kind of know that it is kind of hard to upgrade and change the operating system of the computers are installed it in some factories and those stuff. So yeah, really good use of Docker to help facilitate with and adapt to the rigidity of their computer system. Yeah. Thanks.
Okay, so we are done with 5 minutes of question and answer. So thank you, Jonathan.
yep, thank you.
Yeah. So we'll move on to our second presenter of today, Navina Modu. Navina, please go ahead.
Yeah, okay, thank you. I'll share my screen. Are you able to see my screen?
Yes.
Yeah. Hi everyone, I'm Navina. For my capstone, I have done a project on an AI-powered itinerary app for personalized trip planning. This project aims to simplify the trip planning, use a user-friendly interface and intelligent recommendations by enhancing the travel experience with convenience and customization. Yeah, this is the agenda today I'm going to cover in this presentation. Coming to the problem statement, this problem statement focuses on building a smart travel planning system. The goal is to design a platform where user input basic travel preferences like destination, budget, dates, and the type of travelers, and the system automatically generates a complete personalized itinerary. And this itinerary includes the relevant flight options, hotel suggestions within the budget of the traveler, and the daily activities suited to the traveler type. Next, coming to the motivation, AI improves travel by using the real time data like hotel and flight details to adjust the plans and learn user preferences. And it offers a smarter and more satisfying suggestions. It also saves time by quickly generating personalized trip plans based on the user behavior and interest. Next, coming to the background part, like Smart Travel Planner is a mobile app designed to simplify the travel by generating personalized itineraries based on the user priorities, budget, and the travel period. It also uses the AI powered itinerary generation to create and adapt the travel plans in real time through the advanced language models. With real time integration and personalization, the app connects to live APIs and it delivers a seamless mobile friendly interface that reduces the user's decision making time and it saves the user's time as well. Yeah, coming to related work, I have examined several recent studies. Most of them explored the AI driven travel planning using the real time data and user preferences. Chen applied ChatGPT for itinerary creation, while Verulu combined GPT models with JWT based login in a full stack app. Building on this, my project integrates real time APIs, secure authentication using the Firebase, and generative AI to deliver a personalized, seamless travel planning experience. And I have also implemented the RAGAS framework to evaluate the metrics. Uh, Design and approach. Like this system follows a FOTA architecture consisting of front end, back end, AI integration, and database This modular architecture enables the smart travel planner to be scalable, maintainable, and easily extendable, while offering a seamless and intelligent user experience powered by real time AI. Continuation to the approach part. For the front end, I have used React Native plus Expo, where the user have the login or register option that's done using the secure user authentication via Firebase. And the dashboard, it shows the saved trips by the users. And the trip planner, the user will enter the input destination, dates, budget, and the type of travelers. And the itinerary view, it displays the AI generated daily plan for the flights, hotels, and activities of the destination searched by the user. Coming to the backend part, it receives the user input, formats the AI prompts, and routes API calls to the Firebase and the AI service. Like I have used the Gemma 31B model for the AI integration. Coming to the Firebase, it handles the login or sign up and it stores the user info, preferences, saved trips, and the AI generated itineraries in the Firebase Firestore database. Yeah, this is the activity diagram for my project where the user login with the credentials or register with the email ID and password. If the login successful, the user can able to enter the destination where he want to travel and he can select the type of the travelers and he can select the dates and it generates a trip plan. Mm. Yeah. This is my deployment diagram where the user can access the app using the Expo frontend and the authentication is done by the Firebase authentication and Gemma 31B model. It sends the trip details to the Firebase database and it stores in the JSON format. This slide outlines the key user inputs collected to personalize the travel experience. Each input serves a specific purpose and it is used by different components of the system. Coming to destination input, the user select their travel location, which helps the fetch coordinates and the relevant images. In the traveler type, like based on whether the user is solo, couple, or family or friends, the system customizes the itinerary suggestions. Next to in the travel dates, the start and end dates are used to calculate the trip duration and the structure the daily plans. In the budget preferences, user can choose the budget like between luxury, moderate, or cheap options, which influence the hotel, flight, and activity accommodations. In the authentication data, the user can handle with the email ID and password, like it ensures the secure access and tight trip data to individual users. In the trip context data, all user inputs are compiled and it's sent to the AI for personalized itinerary generation. AI prompt, it is a structured text prompt is created from the inputs and it's sent to the Olama, that is Jama 31B model backend for AI processing. Yeah. This app outputs an AI generated trip itinerary, including the daily plans, flight, and hotel suggestions, and the places to visit. Users can also see a summary card of saved trips and a detailed view with the full itinerary info, helping them plan and review the trips easily. Yeah, this slide shows how I evaluated the AI's travel suggestions. The metrics I have calculated is context precision, context recall, faithfulness, and answer relevancy. Coming to the context precision, like it checks the if the AI accurately user gives the user inputs or not. In the context recall, it ensures the AI considered all relevant info or relevant user info or not. In the faithfulness, it confirms the responses are logical or realistic. In the answer relevancy, it verifies if the suggestions are useful and it fits to the user needs. Overall, these metrics ensure the AI provides personalized and reliable travel plans. Yeah, these are the evaluation results for the two AI-generated trip plans using the ARS framework. The first input, I have planned a 2-day luxury trip to Hyderabad, that is my home country, Telangana, for a couple. And these are the metrics I got for the context, precision, recall, relevancy, and the faithfulness. Apart from the data analysis, these are the findings I got. This slide summarizes the evaluation results of the AI generated travel plans. For this, it calculated the low context precision and recall. The AI showed low accuracy in matching the user inputs. Its suggestions were only moderately logical and useful. Uh, for the areas for improvement, performance was weakest for the short, low cost trips, indicating the need for better input handling and improved itinerary generation. Yeah. This is the conclusion. Overall, the AI trip planner effectively personalizes travel plans using the key user inputs like traveler type, date, budget, and destination. Secure access is ensured through Firebase authentication, while trip data is safely stored in the Firebase Firestore database. And the trip creations are generated by the Gemma model, which creates the structured JSON plans, including the flights, accommodations, and daily activities. These plans are then presented in an easy to understand format, making the planning simpler and tailored for each user. Yeah, this is the future work I have planned. Like we can implement the real-time APIs like weather APIs to plan the trip suggestions. For the trip editing and customization, it allows the users to personalize AI generated itineraries by adding or removing activities and locations. Offline access and caching, like it enables users to view and manage saved trips without using the internet by using the local storage. Advanced security and role management, like it implements features like admin dashboards, trip sharing permissions, and the two-factor authentication via Firebase. And we can also implement the third-party integrations, like it will connect with the booking platforms such as booking.com or Skyscanner for seamless real-time reservations. Yeah, this is the demo for my project. First, the user signs in with the email ID and the password, and then clicks on the sign in button. This is the trip I have added before. For adding the trip, the first the user will search for the destination where he want to. In my case, I have searched for Arizona. Next, he will select the type of traveler. Next, he will select the travel dates, and next he will select the budget, and it will build the trip. It will take some time to fetch the trip details. Yeah, this is the trip added Arizona. You can click on this button. You can see the flight options and the hotel options and the plan details like day 1, day 2. And the JSON format is stored in the Firebase Firestore database, which we have entered before. And the user have the opportunity, when he click on the profile, he can sign out from the app. Yeah. Yeah, these are the references I have took from the previous studies. If you have any questions, you can ask.
Okay, can you hear my question? Can you hear my voice?
Yes.
Okay, yes. So now, what was your big challenge during this capstone project? And then how did you overcome those challenges?
Yeah, my biggest challenge for this is I'm not able to fetch the flight details and the hotel options. Yeah, for the flight details, And the hotel options, it did not fetch the JSON format correctly. I have changed the JSON response. Yeah, I got the output.
So what kind of advice do you want to give to the next student?
Yeah, for the next who are doing their capstone, it's better to do the capstone in advance. Like instead of waiting till the last quarter, they can do in the middle, and they can search for they can do research on the several papers which other people are done. Yeah, that will be helpful instead of doing at the
Thank
last.
you.
Yeah, thank you.
Hey, thanks, Navina. Do we have any more questions for Navina? Okay, if not, uh, we'll move on to our third presenter for today. So we have T. Hong An. Yeah, please go ahead.
Oh, sorry. So my capstone is an AI-powered study quiz generator, or Quizai. I got the inspiration when I was studying for my AWS Cloud certificate. Basically, AWS have a lot of web pages and documentation on how to study and then learn all of their services, and it's very comprehensive. So at that moment, I kind of wish I had some tool to help me effectively get questions and then test my knowledge on each of those services. So the motivation for this capstone is to create a dynamic, adaptive learning application, which will tailor the content based on what the user needs, help them reinforce their weak areas, and also provides real-time feedback with references so that they can improve their knowledge and understanding of any subject. I found some related work with the same idealization of Quizai. Most of them have good use of AI-powered content. However, what they lack is the format of the questions. They're limited to multiple choice question only, and I don't see the options for open-ended questions. Also, since they are only aiming at multiple choice questions, they don't provide assessments or feedbacks to the users' answers for each of the questions. So those are the drawbacks that I aim to improve in Quizai. To create a quiz generation application, we first need to know what a quiz is. It's basically a short, informal assessment that will help test the knowledge as question forms for the users. And to be able to generate the questions, I will need to integrate large language models, which are very large deep learning models that are already pre-trained on a vast amount of data. It will help me generate questions based on my prompt that I want. And since I also allow for user-provided inputs, I will also need to use retrieval augmented generation, which is the process of optimizing the output of large language model. It will reference the knowledge base outside of the training data, in our case, the user-provided document, before generating a response. It will help extend the powerful capability of the large language models to specific domains or internal knowledge base. So for my input, I will have two forms. The first one is a PDF, and the second form is a web page URL. My first task to process this kind of input is to extract the text For the PDF, I'll use Llama Parse, which is a cloud service that is very effective in extracting the text from the PDF, which contains a lot of like complex structure like tables or columns or images. For the web pages, I'll use Beautiful Soup to extract the text. And after we already have the text, we'll need to clean it to remove all of the unnecessary information like headers, footers, references, copyright, paragraphs, or something like that. And then I'll have to extract the concepts, the main key ideas in each of these clean texts. So to use them as metadata before I feed the entire clean text to Llama index. The index here will be used for later processes that involves RAG, which is like retrieval augmented generation. So this is an example of the input and the output. So an input will be like a URL here, and we will scan the entire text in this section. And then once we have done all of the pre-processing, the final output for these web page will be an index on Llama index, sorry. For the application, I will have some main use cases. The first one is authentication and authorization, of course. And then a user can upload their documents, which are PDF and URL. And then these documents will be parsed into text and then will be fed into Llama Cloud. Llama Cloud will also utilize OpenAI for their embeddings. To generate the quizzes, I will use Grok. And then user can also assess their answers accuracy with Grok. With all of those, this is my entity relation diagram. I'm using NoSQL, but basically there will be 3 types of main entity. First one is user to store all of the necessary information. The second one is the document, which will be storing metadata information related to the PDF or the URL that the user provided. And lastly will be the set of questions that the user generated after they have provided the documents. So this is the activity diagram. The user will need to log in first before they are able to do anything. I'll use Firebase authentication as my external service for authentication and authorization. This part is similar to the input-output diagram that I've mentioned above. And for question generation, I will first need to get, like, for each of the document, first I will need to get like a set of concepts that a set of concepts that can be used for generating questions. And then I will use Llama Cloud to retrieve all of the notes with the relevant concept information. And then I'll have to summarize those texts because there are a lot of texts that related to those concepts before feeding them to Grok for generating the questions and sample answer. For each of the question, when the user provide an answer, if it's an open-ended question, the Grok will also be utilized to assess the answer's quality to like bring out what are the missing points from the user's answer. This is the deployment architecture of Quizeye. Basically, I'm using React.js as front end and Fast API as back end. For authentication, as I've mentioned, I'm using Firebase and I'm storing all of the necessary data in Google Firestore. This part I've also have mentioned, I'll use and utilize Llama Cloud for parsing the PDF as well as indexing all of the document. And OpenAI is incorporated with Llama Cloud to work as an embedding model so we can produce efficient embeddings for when we want to get all of the relevant notes. Grok is used for summarizing the documents and generating the questions. So once we already have the application and this is the part where I perform data analysis on the results. So what I do mostly is assess the system performance by checking the API response time, like checking most of the core APIs, like processing the document, generating the questions, and also evaluating the answers. Besides that, I will also evaluate the questions that are generated by Grok to count and check to see like how many unique questions that are created and are there any duplicates among the questions. So this is an average time for each of the API. Since we're utilizing like an external system, so the time is not really real time, but compared to the other papers that I've shown you in the previous related section, it's performing quite okay compared to the other papers. So we have Quizio is quite fast, but it is because they are a paid version. We have like similar performance with PDF quiz, which is also like on average 10 seconds. But for the other papers, they don't provide the API performance system. So I cannot like compare on those. For question uniqueness, it's Quizai is like when they are generating questions for large text, it contains some duplicates question that might be mostly because the context and the date, like the prompt that is being used for generating the questions are kind of short, so the LLM is unable to create like a full 100% unique questions. But in conclusion, Quizai it proves to be quite effective in preparing for various certifications. It allows for user-provided flexible documents, and it also automated the quiz generation process with multiple types of formats. The response time is acceptable, like not too bad, but it's also not too good, which can be improved in later. One highlight for Quizai is that it also offers actionable feedbacks where it references back to the original document, and also it allows for a feedback when the user answers to any of the open-ended questions. For future work, I will try to adapt more document formats such as PowerPoints, Word, Microsoft Words, so that besides the students or the learners can have more format to provide for question generation so they can better perform and better test their knowledge. Also, since I've mentioned that the system performance is not too good, it is also necessary to improve the API response time. One of the solution might be to use a stronger LLM with a longer context limitation. So this is a demo of Quizai. In this part, we're just logging in first before we can access the core functionalities. And then I use like a page from AWS here, copy the URL and then paste it into our application so that it can first process the document first and then generate the questions later. This in real time is actually slower than what I'm shown here. But as you can see, there's a scoring mechanism as well as there's going to be feedback on the answers. Okay, so those are like multiple choice questions. We can also revisit the previous quizzes that we have already generated. So it's kind of the same like mechanism as what I've shown before. So now we can jump straight into how it generates open-ended questions and give feedbacks based on the user's answers. So this is an open-ended question, and now I'm gonna test some answer. And when we check the answer, there's gonna be like a assessment and a score to see like how well we did on the questions. Yeah, so that's the end of my presentation. Thank you.
Can you hear me?
Yes.
Yes. Can you hear? Can you hear
Yes.
me? Okay. So during this capstone project, so what was your aha moment? Oh, this is I learned something new. And also, what courses really helped your capstone project?
What was my aha moment? Is that your question?
Yes.
I think the most aha moment was when I was fixing a bug. Like it relates to the part where I am sending the prompts to the LLM, but it kept saying that my request is malformed. So I had to incorporate a lot of tools like both Cursor and then Grok to investigate like why the bug was happening. And turns out it was because I did not use a proper object that that model was using. So once I like shift to that object, like the entire flow was so smooth and it felt so great to fix the bug. And that was when like I finally finished the MVP for the design here. Is there any other question?
What courses really helped your capstone project?
What course?
Yeah, from the CDU. Then you took. Yeah.
What course? Let me think. I think it's probably like web development because like besides web development, I don't think that we have covered things like LMs. Oh no. Oh yeah. I think it's web development because it helps me first create like a 3-tier architecture for my application first. And then in web development, we also got introduced to how to use LLMs. I think it was Open API or Open AI at that time. So I can leverage that kind of knowledge and put it into this application. And the third is web development also like give us some guidance on how to deploy applications on GitHub Codespace, which I also use in this application, and it's very nice. Yeah.
All the AI courses or data science courses?
For the other courses, probably there was data. I don't really remember the name, but there were some data class that helps me learn about a few evaluation metrics that can be used for like evaluating the LMs and evaluating the results that I have. But I did not focus on that, those metrics in this application, so I didn't mention the data courses.
Thank you.
Okay. I think that Harrison has a question.
So do you plan on commercializing this project or is it gonna be open source? Because I believe Scott and Brian would love to have it in their system.
Oh, open source. Yeah. But to commercialize, I think it's a bit harder to compete with other applications out there because their application is really fast. Like this part right here, although they only accept multiple choice questions, but it's like processing the documents very fast and it's generating the questions also very fast. So unless we have a more powerful LM to, like have our response faster, then I don't think that we can commercialize.
I think it might also depends on the data set that you got as well, right?
Oh, I don't actually have like a fixed data set. Everything input is user provided. Maybe like if we use a different LMs or different model stronger, then we can have a better system performance. But if we don't really want like real time response and we just want to have a set of questions generated, and then I think that this application is not bad. It's good.
Yeah, I mean, if you train it with something like, I don't know, getting the database from Quizlet to populate your data set first, that would actually strengthen the quality of uh, your generated data set. I
Oh yeah,
believe.
yeah,
So, yeah.
I believe that can work. It's just that in this current version, I am letting the user to have all of the freedom of providing documents, so I don't really pre-train the models. That's why. But yeah,
Which, which
you're right.
which is good. I mean, in the future, that could be like one of the directions that you can look forward to, and if you want to strengthen the generated aspect of your model, right?
Yeah, great idea. Yeah.
Okay,
Um,
does anyone else have any questions? Okay, yeah. Okay, thank you everyone. Just stop recording.